Hey everyone, in this video we're going to solve a medium difficulty circuits problem that includes a battery, resistors, and an LED. Our goal is to figure out how much current flows through the LED branch of the circuit. If you're new to circuits or you just want to understand series and parallel components working together, this walkthrough is for you. So here's the setup. We have a 9-volt battery powering a circuit that starts with a 220 ohm resistor. We'll call this R1. That resistor is in series with a parallel section that splits into two paths. Path A contains an LED, which drops 2 volts, and a 330 ohm resistor called R2. Path B, on the other hand, contains a single 470 ohm resistor, R3. So the current that flows from the battery through R1 then splits into two paths, one through the LED in R2 and the other through just R3 before returning to ground. Our job is to find the current flowing through the LED branch or path A. First, let's understand the resistance in the parallel section. In path A, we have the LED in R2. Now, the LED doesn't act like a normal resistor. It just drops 2 volts when it's conducting. So for the resistance calculations, we only count R2, which is 330 ohms. Path B, on the other hand, is much simpler. It has just R3, which is 470 ohms. To find the equivalent resistance of the two resistors in parallel, we use the formula 1 over R parallel equals 1 over R2 plus 1 over R3. Now, let's just plug in the numbers. 1 over R parallel equals 1 over 330 plus 1 over 470. To simplify, we first find the common denominator and add the fractions. Once we add those together, we get a value of 0.00303 plus 0.00213 equals 0.00516. Now, all we do is flip that number to get the equivalent resistance, meaning that R parallel is equal to 193.7 ohms. So that's the total resistance of the parallel section. Since we found the parallel resistance, now we can find the total circuit resistance. Here in step 3, since R1 is in series with this parallel section, we simply add them together to get the total resistance of the entire circuit. R1 we know is 220 ohms. R parallel is about 193.7 ohms. So the total resistance is just the sum of those. 220 plus 193.7 is 413.7. Now that we know the total resistance, we can calculate the total current coming out of the battery using Ohm's law. I equals V divided by R. We have 9 volts from the battery and 413.7 ohms of total resistance. So I equals 9 over 413.7 equaling 21.75 milliamps. This is the total current flowing from the battery before it splits into the two branches. In step 5, we need to find the voltage drop across R1. We already know that the current flowing through R1 is 21.75 milliamps, and R1 itself is 220 ohms. So the voltage drop across R1 is V equals IR equals 0.02175 times 220 ohms equals 4.785 volts. That means that there is a remaining voltage across the parallel network. So in step 6, we find exactly that. 9 minus 4.785 volts equals 4.215 volts, which is the voltage across the parallel network and gets applied to both path A and path B. Now, let's focus on the path with the LED in R2. We're told the LED drops 2 volts when conducting. Since the total voltage across the path is 4.215 volts, that means the rest of the voltage must drop across R2. So, V sub R2 equals 4.215 minus the 2 volts from the LED, equaling 2.215 volts. Now, we can finally find the current flowing through R2 which is the same as the current through the LED. Using Ohm's law one last time, I equals V over R, which is equal to 2.215 over 330 ohms, gives us a final answer of 6.71 milliamps flowing through the LED branch. So to summarize, we simplified the parallel section of the circuit. We added R1 in series to get the total resistance. We calculated total current from the battery. We found the voltage drop across R1 and used it to determine the voltage across the parallel section. We subtracted the LED's 2-volt drop to find out how much was actually across R2. And finally, we used Ohm's law to find that 6.71 milliamps of current flow through the LED path. This kind of problem is great practice for understanding how LEDs interact with resistors in mixed circuits, something that you're going to use in electronics every single time. So if you found this helpful, give it a thumbs up and subscribe for more step-by-step circuit tutorials. Let me know in the comments if you want me to cover capacitor or transistor circuits next. Don't forget to like, comment, and subscribe, and we'll see you guys next time.